time are you leaving tomorrow?
I don't know.
Did you not want to go see Rick Tracks?
Shoot, that is tomorrow, isn't it? I don't know.
What?
Let me talk after I'm done with this.
Okay.
Alright, so I think this is live now. It looks like everything's going. So, let's see. And let's check. So, I'm going to start off tonight by answering some questions from Lindsay, because she's at soccer camp tonight teaching little kids how to play soccer, I guess. So, well, that just made me think about her teaching like really old people to play soccer, and that might be even more hilarious to think about. So, I'm going to start off with a couple of those. So let me get my right screen going here. Okay. So her first question was, let's see. She wanted me to go over number 3 and number 6 on the last exam. And she said she was having trouble telling when something was equatorial or axial, okay? And the answer to that is it depends on how you draw your Newman structure. Because, you know, you can draw them where the very front carbon has something pointing up and looks like an upside down Y, or you can have it with an upside Y. So let me draw what we're talking about here. That one? Okay. So if you have some sort of, why isn't that showing up? Oh, that's a lot bigger than I was expecting. All right, so let's put something here. If I have a big wedged line there, and we'll call that fluorine. And then let's say I have another big fat wedged line here that means nitrogen. Okay, it's supposed to be a 2. So the question is, how do I draw a Newman structure based off seeing the cyclohexane? It's easier if you use a model kit, honestly, for this, but it's very possible to do without a model kit as well. So we could look at a couple different ways, but you basically are having to look down 2 carbon-carbon bonds when you're doing these Newman projections on a cyclohexane. So I'll usually, well, I have to give you which ones I want you to look down. And so let's do these 2 for this example. So fluorine and NH2 looking down it like that. So how do I do a Newman projection for this? Well, if I call that, I'm going to try and kind of color code this. So those will be my front 2 carbons that'll be on my, basically my dots on my Newman projection. And then these 2 carbons will be my circles that are behind, okay? So when you're looking down those 2 bonds, that's what you would see. So draw my dots, my circles, scroll down a little bit. Now, that very front carbon has basically two possibilities. We could have it where this kind of central carbon, the one that's between them, is either pointing up or pointing down, and that just depends which chair conformation you're looking at, okay? You need to pick one. It doesn't matter which one, okay? So, for example, if I want to show it pointing down, then that means on the carbon behind, the purple round carbons that I had, that's the one that's going to go up, okay? Now, the rest of it's just a regular Newman projection. I can fill these things in. Like that, okay? Now, the question is, how do I know which one to put the fluorine on? How do I know which one to put the NH2 on? So, this back here, the one that's behind that has the fluorine, that fluorine is pointing up, right? That wedged line means that it's coming out at us, meaning pointing up. So we need to show that pointing up, okay? This one here is pointing up. This one that I'm putting the hydrogen on is pointing down. So that's how you know. You don't know that it's necessarily axial or equatorial because it's technically both, right? It'll flip back and forth, okay? There's nothing on that front carbon except some hydrogens. Same on the other front carbon. Now, if I scroll back up a little, if I scroll back up a little and look at that NH2, it's also pointing out at us. And so I need to have that shown pointing up. So there's once again two bonds to pick from there. One's pointing up and one's pointing down. So NH2 and then hydrogen. Okay. Now, what I want us to think about is what would be the alternative to that. So I'm going to try and make that a little smaller. So let's do it the opposite way, which is also correct. So I have my starting out basic part of the structure, but instead of having those front carbons pointing down, I'm going to flip the chair to make those point up. So now I have something that looks like this. And then the one behind, that's the one that's pointing down. So it's basically flipped, right? Which is what the chairs do. They flip back and forth. So now, when I fill all those in, and I don't have any room left on my screen to put hydrogens at the bottom, sorry, but that fluorine still has to be pointing up. Flipping the chair doesn't make it point up or point down, okay? If it was pointing up before, it stays pointing up. So in this case, we'll put it pointing up there. And the same with the NH2, it's also pointing up. Fill in my hydrogens, including the ones imaginary at the bottom that we can't see. And what I want to say is, in the top example here, these are in the equatorial position, both of them. And down here, they're in the axial position. We know that because axial positions point straight up and down, and the equatorial point out to the sides, and that's exactly what you see when you look at these structures. So, hopefully that makes sense to answering her first question. The other one was a nomenclature question. I answered that to her online already. Go from a Newman projection to a chair conformation, and how would you number it? So yes, I do expect you to be able to do that, and there are ways of doing that and numbering that, and that's a really good question. So let me start all over. So if I have some sort of Newman projection, if I gave you something like this, what my husband's doing outside. Okay. And let's put an OH here going down. Let's put an iodine right there. A couple hydrogens. let's put something in the middle. Let's put a chlorine. I mean, at this point, it doesn't really matter. Actually, you know what? I wouldn't give us one that has a chlorine in the middle. I'll put a hydrogen there. I'll put chlorine there. And then the rest I'll make all hydrogens. Okay. And so the question is, how can you take something like one? And for me, when I'm looking at these Newman projections, this is the one there that's pointing up. So if you want to call the dot number 1 and then the thing pointing up number 2, the one pointing down, right, we know where that is also. So 1, 2, 3, the big ring, or the big circle's 4, 5, 6, okay? So I just kind of went around, but you can start and number it anywhere you want. I know some people like to start at the one that I put the arrow on because that's pointing up and that's easy to see because it's pointing up. Some people like to pick one that's pointing down. I mean, it's wherever you can kind of anchor your brain on that. So if I look at that number 2 is pointing up, this would be number 2, okay? Now number 1, I can pick either one that's on the side of number 2. It doesn't really matter. So I'll just go 3, 4, 5, 6, kind of around the ring. So on carbon 1, the one that I put the dot on, if you remember, we need to look at that and say, what is on carbon 1? Well, there's a chlorine in the axial position. So check, chlorine in the axial position. Carbon 2 has the CH2 on it, so we don't have to put anything there. Carbon 3 has an iodine and an OH group, okay? The iodine is pointing up, so that would be equatorial, and then the oxygen is pointing down, so that's the axial. The iodine's equatorial, the oxygen's axial. Carbon 4 has nothing on it other than hydrogens. Carbon 5 has nothing but hydrogens, and carbon 6 has nothing. You would want to make sure you draw it where you have the fewer 1,3 diaxial interactions, okay? So that would be kind of a multifaceted problem. That wouldn't be like a small problem. And that would also tend to test you on more than one concept, which I try not to do per problem, but it is possible to do that. Okay, and then fourth question, what kinds of questions would you ask that involve us having to draw things in perspective? So, I mean, there's lots of questions that I could ask to draw things in perspective. But at this point, there really won't be too many questions like that. That's mostly going to be something we'll start working on next week. So that's something we'll get a lot into.